I'm Kyle Adams.
And I'm Karina Adams.
I'm Alina Adams. I'm Melody Adams. I'm Nolan Adams. Yeah!
And today we are putting our world to the test at Dixie State University. Previously, I produced several videos talking about Einstein's equivalence principle. In them, we talked about how Einstein claimed that falling objects don't actually fall. According to him, they stand still in the air, and the Earth rises up to meet them. No, we did not make this up. Both Dr. Perezga here from PBS and the world-renowned astrophysicist Brian Cox vouched for us on that. Here are some links in case you missed them and would like to look more into that. Anyway, one of our major claims against that was, if our weight was caused by the acceleration of the Earth beneath our feet, then we would all weigh the same amount, for we would all be accelerating at the same rate. We base this reasoning on the claim that when we ride in a car, all passengers feel the same amount of pressure when the car accelerates. And in order for one passenger to feel a different amount of pressure, they would have to be accelerating faster than another passenger. So today we're going to start off by putting that claim to the test. Here I have two different scales of different masses, and we're going to stand them upright in the back seat of my car and zero them out. Then we are going to accelerate and see if they both register the same amount of pressure acting on them. Just so you know, scale number 1 weighs 13.6 ounces, and scale number 2 weighs 1 pound and 9.8 ounces. Alright, hold on, I got two scales in the car, they're both zeroed out, standing upright, let's go.
Going 30 miles an hour.
Okay, you can stop now. Okay, perfect. Here's a screenshot from when they reached their climax. And from the looks of it, I was wrong. They are both registering different amounts of pressure. However, there is a possibility that there could be a technical malfunction taking place here, because the scales were not exactly designed to weigh things in the vertical position like this. So, we're going to obtain a second witness by doing another experiment. Dixie State University has a 5-story elevator in their Jeffrey R. Holland building. So we're going to go for a ride and see how much our weight changes as we accelerate upward in the elevator. Okay, we've got Melody on the scale here, and we've zeroed out the scale. Go ahead and push the 5. We're going to go on up.
Here goes.
Stay still, Melody, don't move.
I don't know what's on 8 or 4
Going up.
or 5.
Okay, that's good. That's Melody.
Alright.
Put a 5. Now here's me on the scale, and sorry the kids were walking around on the elevator and caused it to shake a little bit. And it's going to probably fluctuate a little bit, but I'm going to just see.
About 15 pounds.
That's...
You gained 15 pounds.
Where the elevator things? Yeah, until we the...
And then you lose almost 15 pounds.
And next up we have Raina. Right, go to 5. 5 floors up, here we go.
3. Okay, 2.
Oh, it barely moved. Alright, I was wrong. Even though the elevator was applying the exact same amount of force on each of us and causing us all to accelerate at the same rate, we all felt different amounts of pressure, or G-force, acting on us. So we will go ahead and toss the argument that if the Earth is accelerating upward, we should all weigh the same amount, into the graveyard. That is fascinating, because that tells me the speed in a centrifuge applies different amounts of g-force on different people depending on their mass. And that tells me smaller people have to reach greater speeds in order to reach the same amount of g-force as a larger person. I wonder if that's why roller coasters make me sick now, but they didn't used to when I was a kid. Now, let's pick up the pieces and figure out the implications of all this. Do I suddenly now believe that the Earth is actually accelerating upward like Einstein claimed? No. This just proves that if the Earth is accelerating upward, different objects can weigh different amounts. Although, there is a little more to Einstein's claim here. He claimed that falling objects are weightless despite the fact that they have mass. When we zeroed out the scales here, that didn't just magically make us weightless. Our weight was still being applied to the scale, and when we got off it, the scale would go into the negative numbers. We just zeroed out the scale while we were on it to see exactly how much our weight changed as we accelerated upward. Now let's go back and remember the words of the astronaut Mike Massimino.
I'm Mike Massimino, and this is how health is different in space. I was an astronaut for 18 years. I flew in space 2 times, 2 missions on the space shuttle. Weights aren't going to work very well in space. You can take an object that weighs 600 pounds and pick it up with one finger because everything's floating, it's weightless. So you want to be pulling against something for a resistive exercise workout, like a spring or something that has some resistance to it, because that works just fine in space, but actual weights won't.
Actual weights don't work in space because everything is weightless. You have to use a spring because an actual weight won't provide any resistance when you lift it. So following that line of reasoning, if the Earth were to likewise lift a weightless object, the weight should likewise not provide any resistance. However, as we observed, weights on Earth do provide resistance. So, does this kill 2 birds with 1 stone here? Let's tread this ground carefully. Einstein claimed falling objects are weightless, and Dr. Perezgues said our weight could be seen like the backward jolt we feel on a train. So a falling object would be weightless, but would still provide resistance, meaning a weightless object could be heavy, as oxymoronic as that sounds. This simply means that I could hold out a weight and never tire because the weight would be weightless. But if I were to move the weight, then I would feel it resist the movement. This appears to be Einstein's get-out-of-jail-free card, and I'll accept it, as oxymoronic as a weightless weight sounds. That makes me think back to the 2 upright scales in the car. With the exception of air pressure, there was no horizontal force acting on the scales, meaning they were horizontally weightless until they were put into motion. However, Mike Massimino doesn't have a get-out-of-jail-free card. He said a weightless weight wouldn't provide any resistance, and I agreed with him on that concept. So when I was proven wrong, that means I get to take him down with me. And since Mike was wrong, that means Mr. Coyote would have something to worry about if he was accelerating upward toward a massive weightless anvil. But at least that disproves NASA. So I think that's a pretty decent consolation prize. I also find myself still thinking about his name. Massimino. I wonder if that's his real name. Is it just a coincidence here that the word Mino means to confuse, disorient, or make people lose their way? Okay, So, have my claims against Einstein been utterly defeated? No. Let's take a look at my remaining claims that still stand. According to Einstein's curvy space-time gravity wells, if I were to just stand next to a massive object, I should feel heavier. Let's disprove that here and now with an observation. Alright, here I'm going to weigh myself next to a car. There's my scale. See if I can get it to stay still. There we go, 190. Okay, now I'm going to pick this up and go out away from the car and see if it says something different. Away from the car. Does it say something different over here? 190. All right, I weigh the same. Now, on that same note, according to Einstein's gravity well theory, more massive objects should fall faster than less massive objects because they have a steeper incline in the gravity well. So the Brian-Cox experiment, where a bowling ball and a feather dropped in a vacuum and fell at the same rate, that should debunk Einstein's gravity well theory. But Einstein also claimed in his equivalence principle that falling objects don't actually fall. The Earth rises up to meet them. So with that, Einstein's equivalence principle contradicts his gravity well theory.
I got some more explaining to do.
You got some explaining to do, Neil.
Thank you. I could not have said that better myself. Thank you all for watching. This video has been brought to you by the Flat Earth Institute of Science. And here's a shout out to some select members of our debate board: Vimal, Theodore, Hubert, David, and Lucas. Sincerely, thank you all for showing so much interest in this topic and driving me to further test my claims and make new discoveries. I have thoroughly enjoyed this. If anyone else would like to participate, the debate board is totally free and open to the public. There's a link in this video's description. Also, please feel free to check out our playlist. We have every lesson in our curriculum there in order. It's worth checking out.